Just a quick intro about GerritForge. I think you all know us, but yeah, we're an American company, deeply committed to open source and the Gerrit Code Review project. We've been in business since 2009. Yeah, everything we do is open source, and we offer yeah, services and support on enterprise Gerrit installations. I don't really think anybody needs to know much more about us than that. So I'll leave you to the interesting stuff with Punch and Shane.
Hi, everybody. So, well, I'm Fabio Conciroli, aka Punch. You probably saw me around in previous conferences or GerritMeets.
And I'm Shane McIntosh. I'm an associate professor at the University of Waterloo, and I study software engineering using AI techniques.
In fact, today we're here talking about GerritForge Health Service, which is, as you can see from the slide, an AI-driven approach to sustain Git performance under production workload. What's the problem that we are trying to solve? So 90% of the time when people report a Gerrit issue, is rarely a Gerrit issue. Most of the time is actually a Git issue. So it's an issue with the underlying Git installation. And it's not just a problem of Gerrit, it's a problem for any Git server in general. Now, even if you look at the mailing list, you will see that people sometimes chase after Git issue, and rarely is really Gerrit the problem. Now, how we ended up in this situation? Several factors. So the advent of mono-repos brought the consolidation of different repositories in a single repo. The CI/CD became kind of feeders of changes. So think about robots, think about AI generating code review. And the shift to Node.js since basically 2.16 and 3.0, where we started storing metadata, code review metadata, in meta commits. So all of these factors brought to an explosion of all the dimensions of a Git repository. So either be the number of objects, number of reps, or number of pack files. What do we do nowadays traditionally? So traditionally, we just use pretty much a cron tab with a GC. The cron tab can be more or less elaborate, but this is pretty much the solution that we have to tackle with the performance degradation on our repository. So what we see here is a 5-day graphical representation of the number of pack files for a real life big mono-repo. So here we are looking at a mono-repo with 1.5 million refs and 250,000 changes, roughly. So what we can say here is that the number of pack files increase quadratically with the time. And then at some point, magic happened. So at some point, we have this linear degradation of the number of pack files. And if you see this chainsaw, each peak is when the number of pack file goes down, is that the GC that is trying to cope with the increase of pack files that we are having. But it's not enough, because as you've seen at the beginning of the curve, we're just going up quadratically, and then suddenly it goes down linearly. So what's going on? Why at 4 p.m. The number of pack files decrease linearly? Well, because people start to leave the office, at least in this context. So, but I mean, we can't just, hope that people leave the office and stop committing to solve the problem clearly, right? So not all the companies have the luxury of running a nightly GC where everything is fine and nobody's committing. So what if you have a distributed company? So let's, and this is a classic example of it. So much that we're gonna introduce our DevOps on call that is gonna give us an example of what it would do in, in case something happened during the day and it needs somehow to do some emergency operation. So Danny, if you can switch over to Luca. Yeah.
So for the people that don't know me, my name is Luca Milanesio. I'm been contributing to Gerrit since 2011. Wow, 13 years so far. And I am also the CEO of GerritForge Inc. And recently, a few years ago, became Gerrit release manager. And I'm also one of Gerrit maintainers, a member of the engineering steering committee. So in this demo, because this demo is talking about AI, I actually engage with a virtual AI Gerrit administrator with an AI generated voice. So it's not me. And because we need someone to deal with these mess, so this production issue days of working, let's talk to him. So I gave him a friendly name that is Tim, and let's look. Hey, Tim, how things are doing?
Oh my, the production isn't behaving as expected, as you can see on the bottom left. The CI/CD is running slow. I have already tried to restart Gerrit. That is why you see clone times with 0 seconds. But now the Git clones are not responding. Gerrit is on the top left of the window and is now up and running. See the Docker compose logs fgerrit output. As a Gerrit admin, I typically troubleshoot the problem by doing a manual clone directly from the CI/CD box. Let's see, oh my, it is stuck. Let's put Gerrit out of the equation and try to clone directly from the Git repositories file system. It is still stuck whilst cloning. I know this problem well. I also asked the mailing list, and it is always the same pattern. Developers are pushing hard to get the last features through, as there is a big developers conference next week. I know what to do in these cases. I go to the host and run my super duper emergency GC script. I'm running it now with a no hook. That should save my day, right? As it has already been in the past few years. Get GC started, still counting and packing refs. Oh my, the emergency GC is also stuck. Ponch, Shane, I don't know what to do now. Do you have any suggestions for me?
Okay, so I believe we all need to help our friend Tim. So let's get back to Shane and Ponch, and let's see if we can help him out to sort out this mess.
So what our DevOps on call did is just run a GC, but we end up in a kind of catch-22 situation, because when you run a GC, basically the GC needs to read all the pack files on the file system to optimize the repository and try to create hopefully a single path file. But since basically the more activities you have on the repository and the more pack files you are creating, then the GC would probably take longer. And even if the GC finish, it will leave behind some pack files that it didn't manage to pack it in the previous cycle. So you end up in this kind of vicious cycle where you can't really cope, you can't really get to a stable situation unless you ask people to stop pushing, as we saw before. But it's not really a solution. So it's kind of like trying to take a picture of a train, running at high speed and hoping to get the train in a single frame. It's pretty much impossible. So you need to wait for the train to stop at the station. But as we said, it's not always possible. So why can't humans solve this kind of problem? Because every report is different. Every report has different dimensions, different traffic patterns. So it's not something that is doable by a human to manage all these factors. Furthermore, we know that there have been lots of slashing like the DevOps team lately, and it doesn't look like it's going to improve the situation. So we need to switch pattern to solve this issue. GC is not the only solution. GC is one of the tools in our toolbox. How can we somehow use AI to train it and work for us somehow, finding the solution for us?
So I'll tell you a little bit about the AI solution that we've been developing, and we base it on a technique called reinforcement learning. How many people here have heard of reinforcement learning? Couple of people. Okay. So let me tell you how it works, and I'm going to break it down into 4 steps. Okay. So we have an agent, and in this case, our agent, we've codenamed him Franco, and that's going to be important later. Okay. And this agent is capable of taking actions that impact its environment. Okay. From that environment, we're going to take observations about the state of the world that we're then going to use to assess the action that the agent took. And that assessment will feed back to the agent so that it can learn whether its action had a good outcome or a bad outcome. Now, since that's kind of vague and high level, I'm going to dive into each one of these steps and try to explain how we're using reinforcement learning in this context to keep Git repositories operating healthily. Okay, so first, what kinds of actions can our agent Franco take? Well, first, it can do nothing. So when it's given the option to act on the repository, it can say, I don't do anything. Second, it can create a bitmap. Now, this action is typically taken as part of a GC operation, but for this research, we've kind of decoupled it so that it can be one of the actions that our agent is capable of doing as a standalone option. Next, we can repack references. We can also remove keep files. And finally, we could run a full GC. So the agent could decide to run a full GC. Now, a couple of notes here. First, our preliminary experiments suggested that running a repack refs wasn't really helpful. And that's largely because repack refs is typically done by default when Gerrit does a batch ref update. So therefore, the references were typically up to date. So it didn't make sense for the agent to do this also. Second, running a full GC wasn't always a great idea. So first, it could be the kiss of death, like we saw, a node or a repo or a server that's under a crazy amount of load. If you decide to run a GC, you're just going to make the situation even worse. And so we've removed that operation from Franco's toolbox. So instead, he's only capable of doing those first 3 actions. Next, so how are we going to take from the environment a record of the state? And for this, what we're doing is we selected 2 types of metrics to try and represent things that could give Franco hints about what would be a good action to take. So the first one is the number of bitmap index misses. And the second one is the set of, or the count of loose objects and loose references. Now, based on these pieces of information, Franco then selects which of its actions are the best thing to do at any given point in time. Next, let's talk about how we're going to take that state and turn it into a reward. So naturally, you might be thinking that using elapsed time would be a great choice, right? But there are 2 kinds of limitations with this. The first is that elapsed time is going to be subject to external sources of noise. Imagine there's network congestion or some other operations running on the nodes. So it's not going to be the cleanest source of data for us. And the second concern is that if we used elapsed time, it may actually impose an overhead on our experimental environment. So what we observed is that the act of measuring time could actually impose up to a few seconds to a few minutes of overhead on the actions that were being taken. Now, over time, in a large running experiment, this is going to add up pretty quickly. And it also imposes that we have to wait until the complete action is completed before we determine what the reward was. So that kind of slows down that feedback loop, right? So instead, why don't we measure components of the repo workload as our measurement of how to provide a reward. Now, how are we going to do that? Well, to determine what we want to measure, we took a look at some real data. And in this case, we've chosen the QLang repository because it's very active. And we were able to use that as a repository that we inflated to look more like a mono-repo. So QLang on its own wasn't really a mono-repo, but we inflated it with additional traffic to make it look more realistic. And what we observed is that obviously what's dominating the performance measurement here is the upload pack operation. So our reward function is determined based on what happens inside of an upload pack. So 2 of the 3 components are about that. So the index misses is one key component. We also use the search for reuse time as a key component. And finally, we compute a penalty based on how expensive the action was that it took. So if it's doing something, imagine if it did a full GC, that would take a very long time. It would impose kind of a big penalty. Whereas if it did something shorter and quicker, it's going to get a smaller penalty. Now, I'll go briefly into each one of these components of the reward to give you, in a nutshell, how it's working. So to calculate the proportion of the reward that's associated with index misses, we are going to use the pre-action state and the post-action state. So first, you can imagine we were in a pre-action state where we had no bitmap, and then the action was to create a bitmap. In this case, the reward is going to be proportional to how effective that bitmap is. Now, what makes an effective bitmap? Well, it's one that reduces the number of objects searched for reuse close to 0. In a second scenario, we might have had a bitmap that was replaced by a more up-to-date bitmap. And in this case, we have 3 possibilities. That new bitmap is just as effective as the previous one. In that case, we get a small reward. We have also the case where the performance degraded. It's going to get no reward for that. And we have the case where the performance improved, where it will get a full component of the reward for this. Now, there's a third possible scenario where we had a bitmap and now we've removed it. Now, this is only theoretically possible because the action set that Franco has doesn't include cleaning up old bitmaps. So there's no way for Franco, our agent, to delete bitmaps. But if it were possible, our code is currently set up to provide no reward for this. Obviously, that's a bad choice. Let's talk about the component for search for reuse. So this is another third of that cookie that we're trying to provide to train our agent. Again, we're going to look at the pre and post-action state, where let's say that the search for reuse was kind of on the medium scale before the action was taken, and it remains medium. In this case, it's, the agent gets no reward. Let's say that we had a poor performance in the pre-action state, and after performing the action, it improved slightly, so it would get a small reward. And if it did a big improvement, going from high to low, we're going to get a full reward, right? Now, finally, there's that component of the reward that's kind of in the inverse of what we've been discussing. So if Franco does an expensive action, it's going to get no reward. And if Franco does not so expensive action, it'll get a full reward, right? So obviously no action gets it the full reward because there's no cost. Creating a bitmap gets no reward because that's currently the most expensive operation that Franco can perform. And repacking references got a small reward. Great, so that's how we are deciding the size of the cookie that we're going to feed back to Franco, so he'll learn some good behavior. Let's just briefly talk about how we actually implement the agent. Now, I promise I'm not going to get too academic on you, okay? But there are a variety of algorithms that we can use for doing reinforcement learning. We chose the most simple and explainable one to start with. Now, rather than using a deep neural network with millions of neurons that produces like a very opaque decision that we can't really understand, we decided to use an older technique that's very transparent, white box, and is relatively simple to follow. Now, to perform this approach, it's called Q-learning, we need 3 things. We need a discrete representation of the state, in this case, the pre-action state. So we have 3 columns shown here indicating our 3 different state measurements. We have the representation of actions that we have taken in the past from that state. And finally, we have a running total of the rewards that have been received for those actions from those states. Now, this becomes something like a gigantic lookup table, so that when Franco enters a pre-action state, it's going to calculate the representation of that state, and it's going to select from the lookup table the relevant entries. So in this case, we're trying to determine what action we should take from state 521. We'll select from the lookup table those with pre-action states of 521. We'll filter out the irrelevant ones, and we'll just select the action that received the maximum reward from the past. Okay? Excellent. So that was kind of an overview of how we're using reinforcement learning for this problem. Next, you might wonder, how are we going to know if our solution is actually performing well or not, right? So we have an evaluation plan for this. So I'm going to plot for you an outcome measurement that we might be interested in, the search for reuse time. And we're going to conduct an experiment that's going to measure over time the performance of the repository in terms of search for reuse. And we're going to plot different types of scenarios. So first, we'll plot the scenario where we take no remedial action, and we're just pumping traffic in. And eventually what we're going to see is search for reuse time is going to keep growing super linearly like we saw. And eventually maybe a catastrophe happens and the node gets knocked down, right? We'll also implement another baseline that's kind of representing the state of the practice today, which is every so often we'll run a garbage collection routine, right? Now, what we expect to see here is that we're going to see some growth on that super linear trend until we decide to take action and run the GC, in which case maybe we get lucky and the GC improves things. And then eventually we start growing super linearly again, and we decide to run the GC again, where we might have crossed that threshold, and now we've given our node the kiss of death, which just pushes us to catastrophe again, right? And finally, what we're hoping to see is that our agent Franco, when it's running in the operating environment, is going to routinely be taking remedial actions that keep our performance under an acceptable bar, right? And we've, based on this plot here, we've just defined two key performance indicators, two KPIs, right? So the first is the area under the curve, which everybody remembers their integrals, right? No? No? Okay. But in this case, we want to minimize that area under the curve, right? Because lower is better. So you can imagine that the worst possible performance would be one that shoots search for reuse time up to the top here, and then is a flat line, right? And the best one would be one that has 0, okay? And the second one might be, counting the number of catastrophes that happen during the experiment, right? Obviously, those are terrible things we want to avoid. So now Ponch is going to give us a little bit more technical detail about what's going on.
Let's find out why bitmaps are so important. So Shane has been mentioning bitmaps several times, so that they must be important in this context. So whenever we do an upload pack, the client and server try to find out which object the server needs to send over to the client. And when they agree on it, basically the server pack them up in all the objects in a single path file and stream it back to the client. Now, why bitmaps are so important? Because in an idyllic scenario where you manage to run your GC perfectly and you end up with a single path file with a bitmap, the upload pack basically translates in just streaming the pack file over to the client. But clearly, that's not always the case, right? Because as we've seen, you might have traffic coming in. So, and to all the objects which are not in the bitmap, they need to be searched on the file system. So for each object, we need to go on the file system and find in all the pack files the best representation for that object. And you can imagine that that's quite an expensive operation. So it's like, the cost is basically the number of objects multiplied for the pack file. So in our example of mono-repo, let's say that we had to search for all the path files. So we had like 5 million objects times 10,000 pack files. So we are looking at 50 billion loop, so which is quite an expensive operation. So let's say that at some point you get a force push on your repository, boom, and suddenly you're doomed because your bitmap is suddenly invalidated and you don't know what's going on. Why? Nothing happened, and suddenly my performance is that they're just going to the bottom. Clearly, this is not something easy to monitor. In particular, if you are dealing with thousands of repositories and different Gerrit installation, and you name it, right? So it's quite a complex situation. So yet another reason why it's not scalable by just a human looking after it. So which tool we need in our toolbox to make to keep the performance of our repository up to date? We already talked about the GC. GC is divided in 4 phases. So the repacking phases, where we basically generate 2 pack files, one for the heads with its associated bitmap, and one for the non-heads. And then the second phase is the repacking, where we just get the packs on the file system and we put them all together in a single pack file, in a single ref file. And then we have the pruning of the reachable object and the removal of temporary files. Now, as we've seen so far, this is a really costly operation that might never end, as we saw on the graph that Shane was showing us. And yeah, of course, it's really beneficial for the performance of your repository, but it's really costly. Now, the operation that we introduce in our agent is definitely a cheaper and effective operation. And what it does basically a subset of the operation that the GC does. So it just do the repacking of the heads pack file and the creation of its bitmap. Why? Because most of the time we care about pretty much the 20% of the repository which is normally stored in the heads, and that's why we just repack the heads in our scenario. Repacking the non-heads is a nice to have. Maybe you can do it later on, like when you don't have too much traffic on your repository. Now, as we said, GC is one of the tool in our toolset, not the cheapest. How do we train our Franco to pick the best action in that particular model for that specific repository? So welcome to our gym, to the GerritForge gym. So what's the problem here? We can't, as Shane was saying, we can't just leave the agent there for like 1 year learning from our traffic pattern from our repository. We need to speed up things, right? And that's what we do in our gym. So we have basically an accelerated Gerrit version, which is like 1,000 times faster than a normal version. It's kind of a Gerrit in steroids. So it can really serve high rate number of changes. And what we do, we use Gatling to recreate traffic similar to the profile that you have in production, and we basically bombard our Gerrit in steroid. Meantime, we bring up our agent, we attach our Franco to the Git repository itself, not Gerrit. So in this case, we are picturing Gerrit, but it can be any Git server. It can be GitHub Enterprise, it can be GitLab, Atlas, you name it, right? So this is really important. So the agent will act only on the Git repository. So if we compute this action, get a reward at the speed of light. The speed of light, it means that we manage to reproduce 1 year of traffic in a few hours. So basically in few hours, you get the knowledge of 1 year of traffic. And at the end of this process, there you go. You have an agent that is tailored for your repository and your condition. Now, you can bring your agent in production with everything that you learned during this gym session. And the agent will have the action, so the super fast action in his toolbox with whatever he learns during the training phase, and he will just perform the the action as at a lower frequency. So basically, that's how we train our agent as a super fast speed, and then we bring it to the production. So this is the behind the scene of the training of the agent. Now let's see what's going on with Tim or Luca. If you manage to fix the issue that you were having.
Okay, so let's get back to Tim and see how things are progressing. Tim, are you still there?
Thank you very much, Shane and Ponch. What you have presented looks very useful. However, let's be realistic. I will be in trouble if I do not resolve this production issue right now. The GC script is still running, which is good. In 30 minutes, it managed to count up to hundreds of thousand objects, but I have 4.5 million objects to go, and it would take ages to complete. What is more worrying is that the clone I started is still at 50%. The CI/CD is stuck. The developers are screaming and shouting, and I need to join an emergency bridge call now, and I don't know what to say or to do. Badly keeping on firefighting is not the right thing to do. I have installed the GHS's agent, Franco, on my system side by side with Gerrit. Let's start the agent right now. Oh, wow. Franco has already executed a bunch of actions. Let's see them in detail. Nothing action, bitmap generation action done. Let's see the other fields and the metrics. Here we have the rewards exactly as you guys presented. This is complicated. I'm not sure I fully understand. What I do really care about now is seeing if the Git clone works in production. Let me run the test clone again. This is now running, so let's have a look at the results. Oh, wow, already receiving objects? Done already? Well, I don't know, guys, how you managed to do this, but it now makes a lot of sense to me. Thank you, Super Franco. You saved my day and my job. Well, but I'm going to leave Franco running in the background. I would rather have a quiet summer holiday than answer pager duty calls and firefighting with the repo. Now I can connect to the bridge call and say, guys, all good, problem solved. The Git clone now completes in just 30 seconds. The full GC is still running. It would be best to kill it for now. If you're curious how long it would have taken to complete, I ran the simulation last night and looked at the results. Look at the output of my emergency GC approach. It would have taken 336 minutes to complete, which translates to 5.5 hours of processing time on this box with 128 CPUs. Can you imagine my company being blocked for 5.5 hours and the developers not being able to work? Thank you, Shane, Ponch, and our Franco agent. Now that I don't have to spend time firefighting, I should spend more time following Shane's lessons and learn about AI and how GerritForge Health Service can help my Git and Gerrit performance and stability.
I'm really glad that actually Tim still has a job, right? I will say back to you, Shane and Ponch, and let's see the wrap up of this amazing presentation.
Okay, great. Thank you, Luca and Tim. So earlier on, you might remember I presented to you kind of a sketch of what we expected the performance to look like. We ran some experiments already, and what I'm showing you here are 3 different curves in a normalized space between 0 and 1 on the time axis of the X, and 0 and 1 on the search for reuse axis. So this means we've got a unit square. So the areas under the curve are going to range between 0 and 1. And we know that 0 is great, 1 is terrible. Okay, so what we've observed here is that the blue line here shows us if we take no action, this is how bad things will look. And we computed that area under the curve, it's 0.725. So closer to 1 than to 0, not great. So we also did our routine GC run. That's our green line here. A little bit better, 0.56, but not excellent, right? And then we did our Franco run here, and that's that red line at the bottom, which has an area under the curve of 0.009. So very, very close to 0. And now we can put on our sales pitch, you know, and say, oh my goodness, it's 64 to 82 times better, right? Or if we want to talk in bigger numbers, that's 6,400% and 8,200% better But yeah, a massive improvement over the baselines, right? Any questions, we'd be happy to answer them.
If a force push will definitely invalidate a bitmap.
Yeah, let me actually just spend a word on that. So it really depends on the type of force push. So so the point is this one, the bitmap contains all the heads and tags that are reachable from, let's say, the tip of the heads. If you're force pushing, but do not really remove any of the past history from the reachability, then the bitmap is still valid. But typically, this is not what you're doing when force pushing. Typically, you want to force push because you want to rewrite your history, and you want to make sure that basically some of the old commits are not there anymore. And because that one will basically make your reachability reaching object that should not be reached, using the bitmap will be very dangerous, because if you use the bitmap, you decide that that pack file is something you need to send to the client, you may send to the client stuff that should never ever be sent to the client. For that reason, there is a specific path of code that says if the bitmap contains extra stuff that you should not get, the code says take the bitmap, put into the rubbish bin logically, so the bitmap is still there on the file system, but it's not going to be used, and do the full scanning of all the objects. So we've seen that because there was some very special pattern where everything looks quite okay in production. Then at a certain point, there was a big spike in the clones, and the clones that were taking typically 1.5 minutes, they ended up to take 45 minutes. And then we were looking at the logs, we were saying search for reuse, search for reuse. And then I say, let's make a kind of a very simple calculation on how many iterations that search for reuse would have taken. And the calculation was about 5 billion, right? So it means it was running for 45 minutes, but potentially even a lot longer. And I remember that I triggered a discussion on the mailing list, both Jay, Git, and Gerrit. At the end of the day, yeah, the conclusion was there's nothing we can do. That's the way the algorithm works.
I didn't see the concept of penalty, just the reward. Shouldn't the model be trained also by like the stick and the carrot and the stick? So for actions that, okay, it's not bringing any benefit, but it's doing much more damage. Shouldn't be like a punch.
So yes, with a reward function in general, like we can split it into components, some of which are carrots and some of which are sticks, but eventually it boils down to one kind of reward. Now you're talking about
a negative,
a negative.
Yeah, that will diminish the score.
Right.
The score already gained. Like, okay, now you're
right.
Yeah.
You want to balance it out, right? So we have one kind of penalty that we're incorporating right now, which is the cost of the action that we performed, right? If it's a high cost action, it gets very little reward for that component, right? Already we're seeing plenty of benefit, but of course there are infinite ways that we can revise this reward system to include more information. So for example, if we wanted to bring back the GC operation, this is something we talked about a little bit. It would be nice if the agent could learn from history that when we took a GC in this critical state, it tends to bring a catastrophe, right? And it might learn that through a very serious penalty to its reward. But yeah, again, we're still in early stages with this kind of reward system, but you're correct that we can include even more components that might help it to learn to avoid bad choices as well as perform good ones.
Or it could be that what used to be a good technique because of something changed in the whole ecosystem, it's not a good measure anymore. So then that trend should be decreased, right?
Right.
That's code.
Yeah.
That's what I'm thinking.
So there's the concept of a delayed reward, and there's also the concept of dampened rewards for like previous history, right? So it's very popular to use something like a logarithmic decay for a reward, where like the stuff from like years ago that it learned is worth this much, and the stuff that it's learning recently is worth much more. Yeah.
Okay. And the last question I have, it's about this accelerated learning model. You said that you have basically a Gerrit that's like many times faster than a real one. I assume you are using an in-memory file system for that.
Let me take that one.
Sure.
So initially, that was the idea, right? So we are saying there must be the disk slowing Gerrit down, right? And I also remember the cool presentation made by Matthias about Git raciness, all the resolution of the file system. So we actually started, and maybe we'll give the words to Shane, because Shane started experiments with the in-memory file system. Hey, Shane, how did the experiments went?
Yeah, we didn't really notice very much of a difference when we were running in memory versus on disk. And then Luca came in with his cape on and solved the problem, right, Luca?
Yeah, so then I started to say, okay, that must be the config, you know, that there is a specific JGit configuration related to the resolution of the file system. And thanks to, again, to Matthias and his team for, let's say, tuning all that stuff, but still wasn't really improving anything at all. So I started in the usual way that I do performance tuning, that is profiling. I started profiling and say, if the file system is the bottleneck, I should see plenty of calls stuck waiting for the file system. And surprised, there were none. Okay, so we started digging into JGit and Gerrit, and we found so many bottlenecks that you can't ever imagine. Definitely resolved a lot of the bottlenecks into JGit and Gerrit, and I believe maybe that is worth the next, maybe September GerritMeets, going through the details of all the things we have found. I believe there was also Matthias asking me, why are you creating so many changes with the do not merge, work in progress? Because actually those were experiments at the time, that some of them, they will become mature to become part of the mainstream. But many of them, they were doing things that we never imagined they were slow. Just to give you one example that was striking, right? So the way that JGit stores information into the file system is, of course, specifically for the packet refs, for instance, is to get information in memory and then convert it into a binary stream to the file system. But the translation is to use encoding, right? And we use an UTF-8 encoding. JGit, for whatever reason that I don't know, I don't remember, right, uses a custom UTF-8 encoding that is hundreds of times slower than the JVM one. So we just one example, but there were so many other changes, right? So we just flipped that one, boom, it was going so much faster. So a lot of one side effect, a very interesting side effect, I was actually chatting with the Matthias before, is that the forthcoming JGit 7.0, so the new one, will contain a lot of low-hanging fruit that we have found during this research work of GHS. So let's put it this way, even if it would have not been successful with the AI agent, which in turn it is successful. You have seen the demo, you have seen, apart from the voice that was AI generated, the demo was really me, was not AI generated. I created the demo, it's a real environment, right? And even if that would have not been successful, even just the byproduct of finding all these problems and fixing so many of them, that will be a huge benefit for the open source community in terms of JGit improvements and Gerrit improvements.
So maybe I missed. Thanks a lot, Luca. So I was asking about maybe a calendar or a version, which Gerrit version will contain those.
Okay, yeah. So in terms of the release of JGit, definitely from 7.0 onwards, right? Because those changes, they are still work in progress, will need to be tidied up. Some of them that will be merged, others they will not, just because they were making sense for the gene, but didn't make sense in production. The one of the encoding, absolutely yes. But many others, they are kind of debatable, let's put it this way. Also bear in mind that JGit, and in this case, we did a lot of optimization of JGit used in this scenario. But JGit is a library that is used in many other scenarios. Imagine there are commercial products using JGit as a file system, right? For revisioning files on the file system, right? And so some of them, they will be merged, others they will not. But the ones that will be merged, they will definitely find their way in the 7.0 of JGit and the Gerrit 3.11. And the Gerrit 7.0 JGit, you need to ask Matthias, that actually is in the call. And but Gerrit 3.11 is due in November this year.
Okay, thank you. I assume that the changes, I mean, they can be consumed from a development branch or so, in case I want to sit on some experimental version, correct?
They are all there. So they are there already in review. If you look for the changes created, work in progress with the prefix do not merge, those are the ones that we created.
Okay, sounds good. Thanks, Luca.
No problem.
Yeah, I mean, one question would be, where can we find the source code?
There is a slide up if you, with GitHub repo underneath the QR code, it will bring you to the source code.
Okay.
Yeah.
Following on to that is open source. Is GHS
Okay, so the question is GHS open source?
All the improvements of Gerrit are open source, of course. All the improvements of Git are open source. There are two new components that are both open source under Apache 2.0. One of the XD executor, you've seen all the actions and the execution of the actions. That one is open source. And also the collection of the metrics. So we wrote a specific collector that collects repo-specific metrics. They are useful for GHS. Actually, that one, I believe, will make sense also to become part of Gerrit. At the moment, Gerrit takes metrics, but only at coarse grain level with regards to the Git protocol, except if you're using the SSH protocol, which is not good enough, right? So if you're using the HTTP protocol at the moment, Gerrit doesn't give you very detailed metrics. And if you want to build a system like GHS, of course, you really need to understand what are the performance of the specific phases of the clone. I will explain you why. So I believe that Shane already touched on that, but I will just stress it again. You remember when Shane was talking about the time, why it's not a good idea to base your intelligence system on time? Because the time is too flaky, right? Imagine that someone is doing a clone of a repo that is 1 gigabyte, but is connecting through maybe the same network that you guys are using. That's why today was very flaky. So the live stream on YouTube was very flaky, and then the clone takes a very long time. So if you use that metric for the intelligent actions, then you may understand that maybe you need to do a repacking of the repo because the repo is slow. But actually, you don't need to, right? Because there was just one specific client that was a very slow network. That's why we need really specific metrics, and that part is already becoming, let's say, a plugin of Gerrit or part of Gerrit core. With regards to the research work, so we have been engaging with Shane with research, and he's doing a paper at university. I'm really hopeful that will be published soon. And also we have invested 6 months of work of the team working on that. On that part, as any AI project, we are based on, let's say, open technologies, let's put it in this way. So we're using PyTorch and all the open library they are out there. But the evolution of the intelligence created with that will remain part of GerritForge, because this is what we are, right? So the intelligence that we are learning based on that is going to be part of GerritForge. But all the software that we produce as a kind of byproduct with that will be all open source.
The question is, can it be used with GitLab, GitHub? Yes, of course. I think I mentioned during the presentation, but yeah, let's iterate on that. The agent works on the Git repository, so it doesn't care about the Git server you are using, and this is important to stress, because yeah, you can use it regardless the Git server that you're working on. The agent will just learn about the traffic, the workload of the shape and the shape of your Git repository, and it won't care about the Git server itself.
When you say GitLab and GitHub or Bitbucket, you're actually referring to, let's say, companies that got different software, right? So when you say GitHub, you got GitHub, that is github.com, that is managed by GitHub. It's not open source. They do whatever they want, and you don't have any control on that. You cannot use it with github.com. But if you have GitHub Enterprise, the one that you deploy on premises, and you know what the repos are, as you have seen in my demo, you just have, let's say, GHS agent Franco pointing to your repos, and that works out of the box, right? One thing about the metrics, so as I was mentioning, so we are open sourcing the plugin that gets the detailed metrics from Gerrit, and we will also open source the plugins that are getting detailed metrics from GitHub Enterprise, GitLab on premises, and Bitbucket Data Center Edition in a way that any of the GitHub, GitLab, Atlassian, or any other, let's say, vendor or open source product will be able to extract pictures.
Does the model adapt to any shape of model repository, and does the model need to be retrained? That's the question, I guess.
Right. So I guess it's like any AI model right now, it's a very simple lookup table. So it's very much based on what it's seen. So if what you're applying the model to is very different than what it's seen, it's not going to be making very great decisions, and you should probably retrain, right? Now the hope is, like we said, we've allowed ourselves to produce years of data in hours, so we can expose our training, our agent, to lots and lots of different patterns, and it can learn in that lookup table lots of different things. And eventually the plan is to replace the lookup table when we're ready to move on to more advanced algorithms. And those algorithms are a lot more robust to things that they haven't seen. But I would say for now, if you've got a snowflake of a repository that's, you know, completely different than what we've seen, it's going to be, fine-tuning is going to be necessary. What would you add?
I think, yes, something to add is that once the model comes out of the gym, it's not like he stopped, learning. Once you put your model in production, that's the idea of the reinforced learning. The model keeps learning, right? So yeah, you never stop learning. Yeah, Luca?
I wanted also to make a small analogy with the self-driving cars. As you know, self-driving cars, say, have been trained with a huge volume of data coming from real cars going around the country. And they have created a kind of, let's say, baseline model that was used by, let's say, all the data recreated, regenerated, and reprocessed in the gym environment. However, before self-driving cars were safe to drive, for instance, in San Francisco, then they needed to go and continue the training in that specific environment. And of course, making mistakes, right? I don't know if you guys heard that there were also crashes during, let's say, all the training of the self-driving cars in the US, in California. But then they got to a point where the pre-training plus, let's say, on-road training got to a point that was ready for, let's say, the wider usage. And then they moved from the training phase, the gym phase, into the production phase. Bearing in mind that if you had, let's say, for instance, Waymo, taking the model they created with the pre-training, post-training in San Francisco, and apply the same model to a European city, that will never work, of course, because, I don't know, if you go to the UK or to the US and people are just waiting there on the sign on the zebra crossing, the car will stop. But in Europe, things are different. Different countries got different usage, so, and different cultures. So I'm sure that also in that case, it will need some kind of post-training. And the same is true for Franco. So at the moment, we are, let's say, at the first iteration, as Shane was saying. We are really looking forward to see the paper published. I'm sure there will be other people trying similar experiments, and there will be an evolution of this model. So from Franco, this current model, maybe there will be another one with another fancy name. There will be an evolved model. But even after all these kind of pre-training model, there is nothing that is better than, let's say, your repository to do a post-training. We cannot do the post-training on your repository because your repository is yours, right? So, and nobody has it. So it means that also in that case, you will need to get GHS into a sort of in-house gym. And now we have all the tools for doing that. Specifically, one of the tools that we haven't mentioned, that actually Punch is the father of that tool, is Gatling Git. So we rely heavily on Gatling Git with different traffic patterns. So in that case, not just the repo, but also the Gatling Git will need to be tailored to that specific traffic pattern and doing a post-training in a gym environment that we can create for you. So if you're interested, if you find all the stuff that we have presented today is interested, please engage with Shane, with me, and with Punch. And we can definitely, let's say, organize a POC in-house with, let's say, your system, with creating a traffic pattern related to your production traffic, and created a similar gym environment to do some post-training. And after you've done a post-training, then you're ready to go and try that one out in production. Why there is no repacking files as an action, right?
The question was why there's no action repacking pack files.
Yeah, so I will give you a very simple answer. So we have seen that the best solutions are when you do small action with high rewards. So action that takes seconds, maximum 1 minute, with a reward. So if you repack files and the repo is quite big, then the repacking of the files may take maybe half an hour. And in half an hour, your production could be already, let's say, collapsed. So from that point of view, maybe it's something we'll experiment. But so far, we haven't found a way to make repack files lasting just a few seconds. But of course, you could do, let's say, limited repacking of files. Instead of repacking all the files, you can still say, okay, repack just, let's say, a limited set of pack files. But we can definitely experiment. So as Shane was mentioning, we started with 3 actions. There are more actions we are thinking about. And yeah, and maybe doing a limited repacking of files could be an action that we can put in a gin and see the results. And there will be many more. Yeah.
Yeah, just a quick note. I think the interesting thing now is that we have a framework in place. So we have a framework where we can plug in new action. We have a way of training our agent in a time manner. We have a way and some KPI to evaluate if our experiment is working. So the nice thing that we have now is the framework, and now we can play with the different knobs and see how we can get it better.